Okay, we're going to finish up the 7.2 volume disk method today, but we're going to focus on cross sections, okay? And we're going to find the volume based on different cross sections within this diagram, all right? So we're going to look at our diagram where our volume, or we're going to find the volume where we're bounded by y equals 8 minus x squared and y equals x squared. So let's call this first guy, we'll call that y1, and our second will be y2. That y equals x squared. We're going to call that y2 to kind of correspond with our diagram here. So this first example goes along with the fact that we're going to look at square cross sections, and the side is going to be perpendicular to the x-axis. So how do we draw that, and then what does it look like? Because that's probably the toughest part. All right, so the first thing I see is that I have square cross sections, and they're perpendicular to the x-axis. So here's my x-axis. My side is going to be perpendicular to that x-axis. So my side needs to touch the curve, okay, or the two curves. All right, so here's how I would draw it, and then it kind of pushes three-dimensionally. All right, so if this picture right here is standing right in front of you, holding it upright, imagine if you laid it flat, okay? And that's where this diagram comes from. Notice the x and y coordinates are now flat on the ground, essentially. And these square cross sections are coming up out of your paper, if you can picture that. And so what we're doing is we're going to add up the area of all of these squares from this beginning to the back end. And if you notice, it's got this curve to it because as you go along, the side of that square is getting bigger and bigger and bigger, and then it's getting smaller and smaller again. So that's what creates this curve to it, okay? So if we want to find the volume, the first thing we need to do is find the area of each of these cross sections. So since we're dealing with a square, all right, and we're focusing on this side length, so I always highlight the side that is within my diagram. All the other parts are the three-dimensional parts, okay, that are creating the solid. So if we look over here, this is the side we're looking at, okay? I'll try and highlight that. So it's this side of our square, okay? All right, so how do we figure out that side length? Well, if you take a look at our diagram to the right, that side is our blue curve minus the red curve, top minus bottom. So y1 minus y2, and we can go ahead and call that in our in terms of x, all right? So we have 8 minus x squared, which is our y1, minus x squared. So we get 8 minus 2x squared. So this side length is that right here, 8 minus 2x squared. So we, though, need to find the area of this square. So what's the area of a square? It's the side length squared. So our side length was 8 minus 2x squared, and we're going to square that. So then how do we find the volume? Well, the volume is simply the integral of that area of the cross section. Okay, so it's just the integral of the area. So our area is 8 minus 2x squared squared. We're going from our x values. If you take a look at our diagram, these two intersect when x equals -2 and when x equals 2. So those are our limits of integration from -2 to 2 of the area of that square cross section. And then we have our answer. So you could go ahead and throw this onto your calculator, but we're just looking at the setup right now, okay? So if the cross sections are perpendicular to the x-axis, all right, so this cross section is perpendicular to the x-axis, then our area is going to be in terms of x, and the volume will be in terms of x as well. Let's take a look at this second example here. So now we have semicircle cross sections that are perpendicular to the y-axis. But what we should notice is if at some point, if I draw my semicircle here, again, this is the part that's flat on our curve, and the semicircle, this arch is coming out at us. So again, if you kind of look over on the left-hand side, imagine now if you put your paper flat, your x and your y axis are flat, this dome is what's coming off of your paper. Okay, and here is one of those cross sections. So you can see it creates a dome because as we go through, the diameter gets bigger, which then in turn makes that semicircle bigger. And then it gets smaller towards the back. Okay, but what we should notice is when I draw my cross sections perpendicular to the y-axis, there comes a point where now my cross sections are touching different curves. So this top portion, they're touching my blue curve, my y1. In the bottom portion, after y equals 4, they're touching my y2 curve. Okay, so what we need to do is we need to take the cross sections from 4 to 8 and add them to the cross sections from 0 to 4. Okay, so let's just take one of these cross sections out, and we need to focus on the area of this. Okay, and notice that the radius is our x value. Okay, so we have to think about that. Our radius is the x value, so that means since we are horizontal, or we're perpendicular to the y-axis, we need to be in terms of y. All right, so let's kind of zoom in on these cross sections. So this first semicircle, now the cross section that is within our diagram, that's the diameter. Okay, and what does that represent? Well, before we get to the diameter portion, we need to solve for x in terms of y. So we can add x squared, subtract y, take the square root of both sides, and don't forget that plus or minus. Well, again, as we look at our diagram, we can say, oh, well, the diameter is 2x, right? It's this x value to the right, and it's this x value to the left. So we can say the diameter is 2 of those x's, okay? Well, instead of worrying about the plus or minus, we can then just say, well, that means the diameter is 2 times the square root of 8 minus y. So what's the radius? Well, the radius is half of that. So our radius is the square root of 8 minus y from here to here. Okay? So that's going to help us when we get to our area, right? So what's the area of a semicircle? It's pi r squared over 2. In this case, our radius is root 8 minus y squared. And we get our area of this blue cross section as pi times 8 minus y over 2. Moving on to the red cross section, because we'll have to add the blue with the red. So again, we needed to solve for x in terms of y. Our diameter is 2 lengths of x, so 2x. So instead of worrying about the plus or minus, we can just say 2 times x, or 2 times the square root of y. So then what's the radius? It's half of the diameter, so our radius is the square root of y. So what's the area of the red cross section? Pi r squared over 2, and we get pi times y over 2. So now we just need to integrate these areas, and we'll get the volume. Okay, so the area of our blue cross section, and we're integrating from 4 to 8, and we're going to add that to the integral of the red cross section area from 0 to 4. And then we can go ahead and throw that onto our calculator if needed, but right now we're just looking at the setup. We'll go over the diagrams more in class because that's probably the hardest part, is the visualization portion. Let me know though if you do have any questions, and we will certainly address those.